Hi, everybody. Welcome back. This is Jennifer Phillips Russo, Viticulture Extension Specialist with the Lake Erie Regional Grape Program, and you are listening to Between the Vines. Between the Vines is a podcast that's hosted by both Penn State University and Cornell University. My guest host for this whole almost entire year has been Dr. Terry Bates, and he's back to join us again. And we're going to continue his nutrient discussion where the 10 best studies and research projects that have gone on to help formulate why we give the recommendations that we do in our region when we're talking about.
You have a long time to go through these.
I know. Thank you for joining me yet again. I truly appreciate it. And people have been looking forward to these discussions. So today we're talking about pH, sort of like the basis of everything that we need to go through. I guess I say take it away. Where do you want to start with your discussion?
Let's now I have to get this screen out of the way. It's so funny, people on Zoom or on the just listening to it don't see that I'm trying to open and close windows, and I'm like, okay, we did want to mention before we get started, of course, we're going to get off track right away, about seeing any veraison out there in the fruit. So we shouldn't hit, okay, in Concord, veraison usually happens 69 days after bloom, plus or minus 3 days, depending on the year. Usually when it's cooler and wetter, veraison is a little later. And if it's hot and dry, veraison is a little bit earlier. This year, veraison should hit somewhere in the week of August 21st. But you were just showing me a picture where you saw a cluster that some veraison had moved into.
Yes, so I weekly collect Concord berries throughout the region for the microclimate study that we're doing, lake, bench, and escarpment. And I've had noticed some color on the escarpment. So we were talking about,
okay.
Now, we're only 59 days after bloom right now. And you say
So that's early.
It's early.
The question is, okay, was there something going on with that cluster? Like, is it just an anomaly, or is it, does it have some disease or insect damage, something that would cause it to be stressed and start early? Or do you really have a natural early ripening clone out there, which we should identify and propagate?
I agree. And that's why I brought it when we were talking about it. We should be flagging those. So if anybody is noticing it, I should mention, I checked the clusters. There were no stings. It's a very clean vineyard. So there wasn't any black rot throughout the vineyard. So it did. That's why I sent the photo, because I was like, we have some color in here. So if you do find that, I wonder, Terry mentioned we should have some sort of contest. We could definitely have some LERGP swag that could go out there. But just for our region itself, we should be flagging those vines. If you happen to notice color now.
The free LERGP t-shirt for anybody who successfully identifies an early ripening clone. So we've talked to Peter Cousins and Lance Candle Davidson, so geneticists, about this, and they said, oh yeah, with all the Concord that's planted out there, it's quite possible, if not likely, that there are just some natural genetic differences out there. So you have a Concord vine that's a clone that is an early ripening clone, and you just need to identify it and propagate it to see if it's truly an early ripening clone, like we're trying to do with Concord clone 30. And so I think you could use the MyEV thing on your phone, and if you spot a vine, you should geotag it with MyEV and try to be pretty specific about like what the row and vine number is, and then either track it, or we can collect wood from it and then see if it's really an early ripening clone. Wouldn't you like to be the person who identified on your farm an early ripening Concord clone that just revolutionized the industry?
Wouldn't that be great? And you're out there all the time, or you should be, right? You're out in your vineyard. So
I don't know what the legal part of it is, but could you have you could call it, whatever, the Bob Betts clone.
Oh. Yeah. He's giggling right now because he's listening as we go through.
So if you're driving through the vineyard, I mean, it shouldn't be that hard. If you're driving through the vineyard at this time of the year and all of a sudden you just see one vine that's got color in it and none of the other vines do, then that's definitely
flag us and let us know.
We should figure out what wavelength you can shine on the vines. So if they're starting to color up, they fluoresce, So you could drive around at night and then all of a sudden you just see this fluorescent vine. All right, we're getting way off track already.
No, but that's fun. Let us know if you find anything. And I'm going to try to find those vines when I go back out next week, and I'll flag those myself. So why is pH important in vineyards?
Okay, let's make this one quick. We always say that. Let's make it quick.
Right.
I put this on my list, my top 10 list, because this is what we got started on when I first got hired at Cornell. So I had talked to Phil Troop at the time, who was the viticulture extension specialist in Jen's position way back when. And he had all these soil and petiole tests from growers. And the first thing that jumped out of me was, holy smokes, the soil pH was pretty low in most of the samples. I mean, I saw samples as low as pH of 3.5, which is almost unheard of. And averages were around 4.5. So some work, not specifically with pH, but with nutrition stuff related to pH, was done by Nelson Chalice back in the 1950s when he was really concerned about potassium nutrition in the vines, which does have to do with soil pH. So anyways, I was a new hire and looking for projects to work on, and talking about something glowing hitting you in the face. It's like, oh my God, you can't grow plants at a pH of 4 unless it's blueberries. So we were like, there's got to be issues here. So we did a very simple, straightforward potted grapevine study where we took vineyard soil. You can see the little picture. So
Yeah.
we had these 25-gallon pots with grapevines in it. The soil was from the vineyard, but we either used ground sulfur to lower the pH or lime, like most of us do, to raise the soil pH at different rates to cause the soil to have different soil pH. And we actually did it in a cement mixer. We would dump the soil in a cement mixer, add our doses of sulfur or lime, and then put them in, and then we planted vines from Dennis Rack at AA Vineyards and grew them out and looked at the biomass. So we then would, at the end of the season, dig up the vines, look at their root biomass and the shoot biomass, just basically looking at vine size. And we saw a response, which is this chart here. For those of you who can see it, that, below a pH of about 5.2, we started to see a decrease in vine size. So pretty simple, like the vines just were not growing very well at a pH below 5.2, which is what the textbooks would tell you, that below a soil pH of 5.2, you get a lot of aluminum solubility in the soil. So that's like almost an exponential thing. So the pH is a logarithmic function, right? So as you drop, it goes up really fast. Like when you drop soil pH, the concentration of hydrogen ions goes up exponentially or logarithmically, whatever. It goes up a lot. Like
Everybody out there is going, what?
But meaning, yeah, so whatever, if you drop from a pH of 5 to 4, you're not increasing hydrogen concentration by 1, you're increasing it by 10-fold.
Yeah.
Okay.
And I should note that because some people are not seeing this, they're listening to it. This was more than 1 year.
So again, young vines. So the 1998, they were 1-year-old vines, and in 1999, they were 2-year-old vines. So we'll talk about this later, but we did turn this into a field trial. This was just a preliminary, hey, what's the response of vines to soil pH? We didn't crop them or anything. They're just small vines, small young vines. So you get a lot of aluminum solubility, and that messes up a lot of things. So aluminum will precipitate with phosphorus and calcium, or not calcium. But anyways, you just get nutrient getting screwed up. But more importantly, the aluminum will actually interfere with the growing shoot tip or root tips. Man, I can't speak today. It'll interfere with the growth of root tips. And so the roots just essentially stop growing, or they grow very slowly. They can't explore the soil volume, and then you end up with a stunted vine. Um,
That's
we
it.
did
Very low pHs.
yeah, below 5.2. That's why they're like, what soil pH should I be at? Well, I don't care. Anything above 5.2.
I always say 5.5 to 6.5.
Yeah, and there's different reasons why we now suggest that, but like from this study, it's just like, hey, because we went up to a pH of almost 7.5, and there really wasn't much decline in the vegetative growth of these vines. Again, later studies where we did field studies and looked at more of a balance of nutrients with a cropping system, we modified that recommendation.
Okay.
But just based on this, we were like, yeah, we're growing our Concord vines at 4.5, and that's really bad. We should at least get it up to 5.2. And that's why we said, well, shoot for 5.5 at least. And you're going to improve the nutrients. So you're taking aluminum as a toxicity problem out of the soil. And so you're going to have better root growth, you're going to have more nutrient uptake, and you're going to lead to bigger vines. I mean, pretty simple, fundamental horticulture stuff. From a physiology standpoint, the chart in the middle. So what we did was we took a pH reading of like the bulk soil that was in the pot. But when we dug the roots up, I took the soil that was like, so when you dig the roots out, you actually have this soil that's like adhering to the roots. And we call that, yeah, so that's the rhizosphere. So the rhizosphere is it's the plane right next to the roots and interfacing with the soil. We call that the rhizosphere. And plants will do a lot of rhizosphere modification from exudates and differential ion uptake and different, they actually try to make their environment better for them. It makes a lot of sense. They can't get up and walk away, so they got to expend some energy in making where they're growing more beneficial to them. So we looked at the bulk soil pH, and then we looked at the rhizosphere pH. So we took the soil that was right up against the roots, and we scraped that off, collected that soil, and measured the pH of that soil. And I thought this was very telling in that when we had low soil pH, so pH of 4 to 4.5, the roots were modifying their rhizosphere. They were making it more basic. They were raising the pH in the rhizosphere. And again, that could be from root exudates. A lot of it has to do with the differential uptake of nitrogen ions, either in nitrate or ammonium. So a lot of like root stuff works on electrochemical gradients, kind of like a car battery, right? It's like,
I love your analogies. Go for it.
right. You have it uses a charge differential to do work, to do like ion uptake. So opening up enzymes to let nutrient ions in and out.
Right.
And so it'll actually use energy, ATP energy in the plant to pump these gradients to make a charge differential so that it can do work.
Which is a cost for the plant.
It's a cost. It's using some of the carbon that it gets from photosynthesis and energy to like spend that energy to make their environment more benign. Mm-hmm. So at acid soils, the root was actually working pretty hard. The plant was working hard to make the pH of the soil right next to the roots higher because it actually wants that soil pH to be better. And then we saw the converse when we were up around pH of 6.5 to 7, the roots were acidifying the soil right next to the root to actually favor its nutrient uptake environment. And when it was around a pH of 5.5, it was not doing it. Like
you have to use that energy to do that.
The bulk soil pH was 5.5 and the rhizosphere pH was 5.5. So the roots probably were not working very hard at that soil pH to have a good environment for balanced nutrient uptake. So that's kind of why we say, hey, 5.5 to 6.5 is a pretty good. If you're targeting a particular soil pH, that's a good one to shoot for.
So basically what you're doing, if the pH is 5.5 to 6.5, that plant doesn't have to add extra energy that it could put into something else just to change the soil. It can then have more root growth. It could then have more shoot growth. Okay. Basically, get your soils to 5.5 to 6.5.
Right. After this study was done back in 1998, 1999. So, I mean, we've kind of been talking the same thing for a really long time. As far as nutrient uptake, the last chart is showing this antagonistic relationship between potassium and magnesium. So this is something that Nelson alluded to back in the 1950s. That you're whatever, because potassium and magnesium are both positively charged ions, and they basically have what we call a similar hydrated radius. We won't go into what that means.
Nope.
It just means that the plant can have a difficult time discerning between picking up potassium and magnesium. And I think the current research has shown that in the root system, you have potassium specific proteins for shuttling potassium across the membrane. And you have magnesium specific enzymes to shuttle magnesium, but it's the magnesium ones that are kind of sloppy, that they'll let in potassium as well.
Okay.
So what you end up having is, like, if you have a situation where you have high potassium and low magnesium, like, it's the potassium they're going to compete with each other in uptake because the ion specific enzymes aren't so specific. They're a little sloppy. So at low soil pH, so again, this has to do with soil chemistry. At lower soil pH, the solubility of magnesium and calcium is lower. So you end up with a lot less of that. And then as you raise the soil pH, you get a lot more calcium and magnesium. And it's the magnesium specifically that outcompetes the potassium. So we tend to see at really low soil pH, you tend to have high potassium and low mag. And as you raise that soil pH, you end up having high mag and low potassium. And we'll talk again later in the field study where we start cropping these systems that we know that the fruit requires a lot of potassium. So if you raise your soil pH too high and you have a lot of magnesium and very little potassium, and then you have a high potassium demand by the fruit, that's when we run into trouble. We get black leaf symptoms from veraison to harvest, and we can talk more about that later. But again, this study really showed that a pH of around 5.5 to 6 was really good because you had a nice balance between the potassium and magnesium, not only in the soil, but in plant uptake.
So this is probably going to throw you a curveball, but I'm hoping you'll be able to answer it. You were able to change that soil pH relatively quickly because you did it in a cement mixer and you knew what you were starting with. If we are going to amend our soils, do you know how long you can anticipate without, I know that we've done studies here at the lab at the Cornell Lake Erie Research and Extension Laboratory where we've actually sort of aerated the soil by poking holes in it so that we could get some lime further down in the soil profile. What? Is this a whole nother nutrient study, by the way?
No. No, it's good. So our recommends are always like, you have the best opportunity to change the soil pH is in a pre-plant situation. And so normally we'll do a soil test before we plant, and it will say, okay, I got to add, the recommend may come back to say, oh, you're a pH of 4.5. And based on your soil type, you're going to have to add 5 tons per acre of lime to get it to 6. And what we'll do in that case is we'll apply half of the lime and we'll plow it in as deep as you can plow it in. And then we'll put the other half on, we'll disc that in, and then we'll plant the vineyard on top of it. That's the best scenario. In a established vineyard, okay, lime is calcium carbonate or calcium and magnesium carbonate. And when you put that on the top of the soil, the calcium and the magnesium ions, when they dissociate, that'll move through the soil profile really easily, but that doesn't change the soil pH. It's the carbonate that changes the soil pH, right? It's Tums.
Yeah.
So, you have heartburn and you take some Tums. It's not the calcium and magnesium carbonate that's in the Tums that does anything. It's the carbonate that actually sucks up the excess protons and changes the concentration of pH, which is what pH, that's what
Right.
pH is a measurement of, is the concentration of hydrogen ions. So we always say no more than 2 tons of lime, well, 2 to 3 tons. You know, you don't want to get above 3 tons of lime per acre per year. And usually what we just say is just keep doing that. Do 2 tons per acre of lime per year until you get the soil pH where you want it. Again, the problem is that the carbonate does not move very well through the soil. One soil scientist told me once that like you have to almost neutralize the upper soil profile before it'll start to move down into the profile. So there's ways that we have talked about getting around it. Some people use aerators, or you can run like a shank through and drop the lime in behind it. We've talked about doing lime slurries behind a shank. If you can get the lime, physically get the carbonate into the soil deeper, that's going to be better for you than just keep putting it on top and waiting for it to react. Having said that, we have pretty good luck if you put 2 to 3 tons per acre on the surface, you come back next year or the year after that, put another 2 tons on. So here's a fun thing that I usually say, I think this is common knowledge, and then people are like, I've never heard that before. So we use urea or ammonium nitrate fertilizer almost annually, right? Most of our growers put on nitrogen every year, whether it's 20 pounds, 50 pounds, 100 pounds.
50 pounds.
So those fertilizer sources have an acidifying effect on the soil, which is, I think, why when I first measured all that soil pH with Phil Throop, it was like, how are we getting soil pH that low, like 4? It's because you're applying ammonium nitrate fertilizer or urea fertilizer every year, but you're not adjusting for lime. So there are recommends out there. If you put down X number of pounds of ammonium nitrate fertilizer, you should be putting down so many pounds of lime with it to not have that acidifying effect going on in the soil. So
Makes sense.
So it's kind of that thing. If, I've been applying nitrogen fertilizer forever and I never put on lime, you should check your soil pH. It's probably been drifting downward to the point where you need to really do some adjustment with lime. Did I have another?
I think you had one more. You said you had 2 slides you wanted.
Yeah. So this is not necessarily related to soil pH, but it was other stuff that we did in that potted grapevine study. And we had some other potted grapevine studies, some with Greg Loeb, where we were looking at Phylloxera, and then the one we were in the soil pH trial, we looked at Mycorrhizae infection because I was thinking, okay, maybe one of the issues is at different soil pH, maybe I'm disrupt. So, okay, let's back up. Grapevines are obligate vesicular arbuscular mycorrhizae plants, right? If you grow a grapevine without mycorrhizae, they're really stunted because they're not very good at picking up phosphorus. And they put vine energy into forming these associations with specific fungi, vesicular arbuscular mycorrhizae.
Nice job.
So the plant gives the fungus carbon for life, and then the fungus, which is they have these vesicles and arbuscules within the root system. They form an association with the root, and then the fungal hyphae go out into the soil and pick up immobile nutrients like phosphorus. So we said, maybe they're doing really bad at low pH because we're screwing up the mycorrhizae at low pH. But when we did the staining and analysis of mycorrhizae, they were like on all the roots.
So it was not an issue of pH with mycorrhizae.
It was not. So again, this might have something to do with rhizosphere modification, that the plants are trying to make it an environment that is better for the mycorrhizae to infect the root system. What we were unable to measure was how far the hyphae go out into the soil. So maybe low soil pH does screw up hyphae growth into the soil, and you get less surface area and less nutrient uptake. Just us, I don't know how to measure that.
Right. Well, it seems very tough. You'd have to get every little hyphae out there.
And you can't even see them when you're
Right.
digging up the root systems. You can't even. They're so fine, these little filaments, that there's no. I don't know. There's got to be more of a DNA way of doing that I don't know how to do. The other thing was the deal with Phylloxera. That people say Concord roots are resistant to Phylloxera, and that's not necessarily true. They're tolerant of Phylloxera, but Concord does get infected by Phylloxera. It does reduce its absorptive surface area. It's just that we manage our way out of it. So Concord roots have Phylloxera. Phylloxera is messing them up, but it doesn't kill the root system. And so we do stuff like, we kill the weeds and we give the vines fertilizer. We just kind of do these, what we consider our general practices, but we're really trying to overcome the negative impact of Phylloxera on our root systems. And you could put it on a Phylloxera resistant rootstock, and then you wouldn't have to worry about it. I talked about this. I gave this example at the JESCO meeting when I was giving the Nelson Chalice talk. He clearly showed that you could have own-rooted Concord that you did more intensive water conservation, right? You gave the vines water through weed control, and you gave the vines nutrients through fertilizer application, and you could get your 2.5 pound vine. Or you could take Concord and plant it on 309 rootstock, which is Phylloxera resistant, and do nothing. Like, you didn't have to do weed control and you didn't have to do fertilizer applications, and you got a 2.5 pound vine, and those two vines were equal. So Nelson showed that it was that you needed to grow 2.5 pounds of pruning weight. It didn't matter how you did it. Like, you could have an owner-rooted system and do everything you can to overcome Phylloxera, or you can have plant it on a rootstock and do nothing, which sometimes still puzzles me why we don't do more work, or we don't plant more vineyards on rootstock.
There are some out there. There are some Concord plantings out there. So.
Okay, that's it. That was the series of potted grapevine studies that we did. So soil pH, Phylloxera, Mycorrhizae, just kind of get an idea of, what's the biology of the root systems of Concord vines, and how does that interact with our management practices?
So just a quick question, and back to the Phylloxera, was there an impact between soil pH and Phylloxera?
No, I don't think we formally measured it. So there was Phylloxera on all the pots. Yeah. I mean, I don't know to what degree, like if, one had 80% and the other one had 60%, I don't know. You dug them up and you're like, oh, look at these root systems. They're all knotted up. And then we did a series of potted studies with Greg Loeb, where we actually had pots where we had owner-rooted vines and grafted vines, and with and without Phylloxera. And so we actually had to use a special netting over the pots to keep the Phylloxera out. So we could actually have own-rooted Concord vines without Phylloxera. And then we had like irrigation on top of that too.
Is that what this picture is that you're showing us, with an obvious smaller root system?
Yeah, so we have one root system, has a lot of nice fine fibrous roots, and that could pick up nutrients. And that was an own-rooted vine without Phylloxera on it. And the other one is just showing you how messed up the root system looks when the Phylloxera are eating it.
What jerks! It is quite a difference.
So, yeah.
Okay, so then you were infield, yeah?
We'll save that for another time.
Okay, good.
This is just the potted stuff.
So you'll have to stay tuned for next week.
We don't want to get too long.
But I do, since we have you as a captive audience. Want to talk a little about this season here. So just in
Yep.
keep in mind for our listeners, we are located in the Lake Erie Regional Grape region and also the Niagara Escarpment. So we follow the lower half of Lake Ontario all along Lake Erie and into Pennsylvania, Erie, Pennsylvania County in Lake Erie. So I want to say it's about 54 miles of shoreline. Does that sound about right?
Yeah.
So anyway, in this specific area this season, we are noticing that berries are a little bit bigger, like 3 to 5% bigger this year, and also hearing high tonnage out there as people are doing some crop estimations. I know you've done work in the past, and I just wanted to make sure our listeners had timely information on if you're going to fruit thin, the best time to do that. And since you've done the research, I would like you to be the one to describe that. I know what I would tell people, but I always just go to you first to ask.
Yeah. Okay, first of all, we measure of course, we measure the berry curve every year in Concord. And so this shows the current year berry curve. So the red line is this year, and it's showing that the berry weight is a little bit larger than average. There's one more data point on here, and it's like 2.45 at 60 days. So it's still below the 2.5 line there on that chart. So it's still, we're into lag phase of berry development. So we get a rapid cell division in the stage 1, stage 2. There's more energy going into seed development. So we get this lag phase, they call it, stage 2 in berry development. And then when we hit veraison, we'll go into stage 3. So anyways, we're in stage 2, berry weight's a little bit larger than average. So we're saying like our standard curve at this time of the year, we're about between 75 and 80% of final berry weight. So if you're still doing any crop estimation or thinking about thinning, that's where you should be in your calculation, is that we're 75 to 80%. Some of that higher berry weight does probably have to do with the wet weather that we've been having lately. But the other thing we put into the crop update. So we look at growing degree days prior to bloom. So in the 2 weeks pre-bloom, we look at growing degree day calculation, and that is actually predicting what the final berry weight is going to be. I think it has to do with the number of rounds of cell division that are happening in that developing flower before it gets pollinated. And so actually, the cooler it is, so the lower the growing degree day accumulation is prior to bloom,
2 weeks prior to bloom.
the larger the berries end up being.
So if it's cooler, like it was this year as we were going through it,
Yep.
the larger the berries.
Right. And if it's hot before bloom, we have smaller berries. And I don't know what the physiological response is. Again, I think it has to do with the cell division that's happening in the developing flowers. But data from this year is showing that, so at our lab where we collect the data since 60, we have an average berry weight of 3 grams, and the pre-bloom growing degree day model says that we were going to have 3.1 gram berries. So, somewhere in the 3 to 5% larger than average, which is now what we're actually starting to measure now. And so I hear a lot of people say, oh my God, it's raining and the berries are blowing up, and what's going to happen? And most of this was predicted by bloom that we were going to have larger than average berries. I think there is a weather component to it. So like we have big berries, like you have so many cells in that berry, and now those cells have the opportunity to blow up with water with all this rain. So there is I do think there's a weather factor in there, but it's not all rain. It's actually some of it happened earlier.
So we have bigger berries out there. And veraison is at approximately 10 days from now. 10 to 13 days from now. So the plan is now focusing on seed development, and in my head, it makes sense that it would be a good time to shake off some of that fruit before it then focuses on the ripening process.
Yeah. So, uh, yeah. So your question earlier was, can I still thin and get a response?
Yes.
And the answer is yes. So this is going back to the article in 2003 that we reference every year when we go to do fruit thinning. So how do you go about doing 30-day after bloom fruit thinning that at 30 days after bloom, the berries are 50% of their final weight, and that's a good time to go out. And then we do, if you feel like at 30 days after bloom, you have to do thinning, you can do that. And why do we recommend that time? Because if you talk to the guys in the wine industry, they may do cluster drop like right at veraison. It's like, why do they wait and we don't wait? And a lot of it has to do with whether or not you want to gain vine size or not. So again, this is the article from 2003, and we can probably post it on the website. Okay, this chart here was, so we thinned at different times of the season, 20 days after bloom, 30 days. So 20 days after bloom is too early to do it with a machine. The berries are too small. We actually had to thin these by hand. Then 30 days after bloom, the berries have enough mass where we can start shaking them off the machine. Then we did it at 50 days after bloom, veraison, and at 14 days after veraison. You were going to ask a question.
I was going to, because I know we're going to touch on it, and I want to make sure that we touch on it. You have to use more force at 30 days after bloom to shake those tiny berries off than you would have to use now.
Yes, just right. At 20 days, they don't have enough mass. You have to shake the vine really hard to get the fruit to come off. 30 days, they have more mass. You can shake them, they come up. At 50 days, 60 days, 70 days, like the berries, again, they're at 80% of their final weight. So this week, 2.45 gram berries or something like that. So they have more mass. You shouldn't have to shake them as hard to get them to come off. So you have to do some field trials.
Thank you. That's what I wanted you to
do. I do some thinning. Yeah. I set my machine up, I shake some off, and then I got to measure what I took off or go back and remeasure what's still left on the vines to, make sure you're hitting what you want to take off.
Right. Meaning
okay.
you don't need as much force to shake off fruit at this point.
Yeah. So that time of thinning research, what it showed was the earlier you thin the vines, especially for small vines, you'll get a vine size response. So, right, once the fruit is set, the vine has to take its photosynthetic energy and it has to put it into the fruit or into the vine. And that's vine balance, right? You're trying as a manager to balance those vines. So if you can reduce your crop early, then the vine has that opportunity to put its energy into the fruit and the wood so that you have a good crop for next year as well. If you wait until this time of the year, or just pre-veraison, you will still get a Brix response, but you're not going to get the vine size response anymore. But that might be okay. Like if you're like, oh crap, I have 15 tons per acre out there, I'm not going to ripen it, I got to get some of this fruit off so it ripens, fine. But if I have a small vine and I'm saying I'm going to thin it so I should come back with a bigger crop next year, that's not going to,
it's too late now for that.
It's too late. Like you've missed the beautiful July that we had to capture all that sunlight energy and put it into the vine. It's, that's gone. All you got now is the rest of the season.
And we should actually that's a really good point to make, because the days are going to start getting shorter. They're starting to get shorter, so you're going to have less light. So that taking that fruit off earlier makes a ton of sense if you're going to take advantage of those longer days.
Yes. If you look at research, similar research to this done in longer growing season areas, where they may have a month or a month and a half after harvest of photosynthesis still going on because the leaves stay on. And even if they have shorter days, they're still getting a lot of sunlight days where there's no crop on the vine anymore. Like people are like, what's the big deal? Thin it veraison and you'll get your Brix response and the vines will be fine. And you're like, yeah, but you have a month and a half of growing season after you pick the fruit. And as all of you know around here, you can pick the fruit and the next day the leaves could fall off.
Right.
So we don't always have the luxury of a post-harvest ripening period for the wood. Okay, so this data is showing, so we looked at the rate of sugar accumulation from veraison to harvest in vines that we thinned at 30 days after bloom. So whether we had 100% crop, 75% crop, or 50% crop.
Okay.
Right, you can see that the vines all start off at the same Brix level at veraison, right? So when we hit veraison, we're about 7.5 to 8 Brix, almost always. Almost may be a good indicator of when veraison really happens. And then
Regardless of how much crop is on there.
right, so you get the rate of sugar accumulation then starts to separate. The smaller the crop or the better the crop load balance, the faster the sugar accumulates. And if you have a heavy crop on there, it's slow. I mean, that
Makes sense.
that's intuitive. I have a vineyard over here. It's got 10 tons per acre on it. It's going to take forever to ripen. I have one over here that's 5 tons per acre and it's dead ripe at the beginning of harvest. We all know that. Okay, so the dotted line on there is when we thinned 2 weeks post veraison. So it's like, okay, veraison hit. I got 2 weeks in. I realized, oh, this crop's not going to ripen. Can I drop crop now and get the rest of it in? And the answer was, and we dropped it to 50% crop. And the answer was no. You can see from the slope of the line that, yeah, sugar accumulation, from the rest of the veraison to harvest time, like it did go up. The rate of sugar accumulation did go up where we thinned late, but it wasn't enough to recover all the way to the 50% crop level, right? So you can speed it up, sure, but your days are too short at that time. I mean, think about what it's like sometimes around here in mid-September. It just like a hurricane comes up the coast and it's raining the whole time and there's no photosynthesis going on. So whatever. Bottom line is the earlier you thin, you'll get a Brix response and a vine size response. The later you thin up to veraison, you can still have a Brix response, but you're going to lose your vine size response. And if you thin post veraison, yes, you can increase sugar accumulation, but you're starting the track race way late. You're like a lap behind everybody. It's just too hard to catch up.
I think this is all really great information and important stuff to hear over and over again, is that keeping those vines balanced, you're going to get your crop, providing that we have the sun. If you push it, I've just heard from so many growers this season, we have a lot of tonnage out there. I said, are you going to thin? And they're like, no, I don't think so. Yeah. I'm like,
yeah. So I always say, this is the intersection of economics with viticulture. The reason they're not thinning is because our economic situation favors pushing a heavier crop. And that's the reality of our industry. And we just do a really good job of playing on the edge of the cliff and trying not to drop off. And I think that's what makes the growers such smart businessmen and smart farmers in this area. It's like, it's not easy. I talked to some of our colleagues in California and they say, yeah, growing Concord's tough in New York, short season growing area and economics. In California, you stick a vine in the ground and you water it.
That's it.
And I'm oversimplifying it, but I mean, to them, everything is about water and controlling water and understanding how the plant uses water. And ours is everything else. Crop load management, nutrition management, disease management. Yeah.
Which we're so very thankful that you're here to study all of that and share with everybody. Appreciate you joining us yet again. What is our next topic for the next nutrient? What slide are we on? What number are we?
We're almost done. I think that was number 6. So number 7, I think, is going to be the field study with soil pH and cropping levels and irrigation. Yeah. So there's a little more to it. And all that does is refine, all of that research has done is refined how we do our nutrient management based on cropping, like when we're really pushing the vines. Again, when we're living on the edge, trying not to drop off the cliff. Like
if you don't want to drop off the cliff, stay tuned.
Right. How hard can we push them and make sure our nutrients are still balanced in the vines?
Well, thank you again for joining me. If you guys are watching this on YouTube by any chance, you may leave comments below and we can address those as they come, or you can always email me at jjr268@cornell.edu, and I'll be sure to pass those questions on to Terry for the correct answer. And thanks again for joining us. Hopefully we'll see you all next week. If you have any questions about thinning and you want to have a little more information on that, please reach out. All right, Terry, we'll see you next week. Thanks so much.
Thanks, Ed.
Bye now.